So that Titan has been created for. But we can see this would be hydrocarbons running on the surface and running into those rivers.
Earth was like this once?
Could have been. I mean, certainly the atmosphere is very similar to that of the Earth's early atmosphere, 3.8 to 4 billion years ago. And there's nitrogen there, there's methane there. What we're seeing is probably the result of hydrocarbons flowing on the surface, and possibly a sea on the surface.
Venturing quickly into the realms of science fiction, because we only got a few seconds later, Earth's going to run out of time one day because the sun's going to cool down. Could that place turn into an Earth-like planet, in which case, can we all nip over there?
Well, later in the sun's history, it will explode, will become a red giant, it will engulf the Earth, I love that phrase, it will do that in about 5 billion years.
Yes.
Now, at that time, the outer solar system could be warmed up, so Titan could be a tinderbox of life waiting to start. All the ingredients are there.
It's so reassuring to know that there might be somewhere else to go in several billion years' time. Thank you very much indeed for that.
Andrew's looking a little uncertain about that idea.
I think that's science fiction rather than science fact.
Absolutely. We'll see.
And we are expected to hear more from the scientists at the European Space Agency's mission control in the next half an hour or so. We'll also be able to see some new images of Titan, so if you'd like to see those, stay with us on News 24. Now, hundreds of rare and valuable motorbikes were reduced to cinders in a fire at the National Motorcycle Museum.
Heard the baby crying. We still can't understand what it tells us, but clearly it tells us that the probe is alive. The entry has been successful. We are on the parachute, and the probe is transmitting. So we are very, very pleased here. I tell you, there is a lot of emotion in the room. I can't describe what I've been seeing in the past few minutes. So it's really great news.
The next step will be to get the real data. This will only happen this afternoon, but we're very, very happy that the probe is under the parachute and doing what it's supposed to do.
The dream is alive. Alive for time enough to say that this is certainly already an engineering success, and we shall see later during the afternoon if this is a scientific success. This morning we had an engineering success, and we can say this afternoon that we have also a scientific success.
And so let's now go to the first concrete visualization of Titan that we've received, data that was received and processed by Marty Tomasco's team just a couple of hours ago. 3 pictures that we have.
Billion kilometers of space, the Huygens probe has transmitted pictures of a complex and diverse landscape scarred by canyons.
Up. We have a picture of a surface that looks, here we are, Marty.
Yes, this is an image we took from an altitude of 16 kilometers. It covers a wide field of view. It has a scale of about 20 kilometers per picture element, perhaps 40 kilometers per resolution element. And for the first time, we can see some of the features that we've been expecting to see and hoping to see on Titan for a long time, but have been very frustrated by the views from the orbiter that have a resolution of a kilometer. So here, instead of a kilometer, we have like 40, 50 meters. We have 20 times better resolution than we have seen from orbit. And finally, we have enough resolution to see clearly these darker, what seem to be drainage channels. They don't quite have the right structure for rain drainage on the Earth. There may be box canyons, there may be some seepage out of the walls of these canyons, as there is on in the western United States, for example. And along the right side of the image, we seem to have a shoreline, perhaps with a few islands in it, or something of that sort. In any case, it's the first picture that's been clear enough and sharp enough for the geologists on the various science teams to actually sink their teeth into and begin to try to understand the features in a way that we just couldn't quite do from orbit. So they're very excited about it, and we're very excited about this picture and the others that we have as well.
Let's go on to the second picture now with these three very dark patches. One of them looking like a glove at the bottom.
Right, these are bright regions near the probe landing site, and they're the kind of terrain that was seen from orbit from the VIMS imager. But we can see this area now rather more clearly. This one is taken from an altitude of 8 kilometers, but it's a different camera, and it has about the same linear resolution as we had on the other one, about 40 meters or so resolution. And what we see is the bright regions are crisscrossed by darker, again, what may be drainage channels, and the dark regions appear to have sharp boundaries with the bright region. They're very suggestive of areas that either have flooded or are flooded at the moment. We will have to do more analysis of our data. We will have reflection spectra of the dark regions and the bright regions, and maybe it will say something about the composition of these regions. But for the first time, we see that the dark regions seem to be rather flat and featureless, and the bright regions are candidates for elevated terrain that have some channels cut across them. And it's really the examination of these images with 40, 50 meters resolution with the broad view of the whole disk from the orbiter that I think will give us some real understanding of the surface processes on Titan, how this landscape, this fantastic landscape was formed, and how it occurs.
Any idea about the little pock marks that appear, whether it's on dark surfaces or on the grey upper edge, for example, looking like pearls of sweat on a bit of glass?
They're pearls of sweat, all right, but the sweat has yet to be shed by our team to remove them. They are unfortunately artifacts in the images. These are the very first raw, completely raw images that we've made from the data sets. And we know there are artifacts in them, and there are some features like that that appear in every image, and we just have to find where they are and divide them out, eliminate them. So it's really dangerous to carry the interpretation of these first frames too far, but the sharpness of the boundary between the bright and the dark, and the elevated terrain in the light, and what seems to be at least flatter terrain in the dark, we think some of these conclusions will hold up. We also will continue to work these over the next days and weeks, and remove the artifacts and make the images in a much better and more understandable presentation.
Right, let's move on to the third and perhaps a really surprising one. We've really got there a landscape, a flat landscape with, looks like rocks, Martian rocks.
It looks like rocks. We think probably they're not silicate rocks like you have on Mars or like you'd have on the Earth. They may well be large ice boulders, large blocks of water ice that is frozen hard as rock on Mars and may be subjected to the same kinds of erosional forces or wind erosions or motions in landslides and things that objects on the Earth are. I was struck by how similar this landscape looks to what we might see on the Earth, what we've seen on Mars, what we've seen on a variety of planets, that even though Titan is so different, so cold, so far away, so shrouded in this veil of mystery, that when you tear it away, the same physical processes are occurring there as have occurred in other places, and we may really be able to understand it very much better by these images. You can almost imagine yourself standing on the surface and looking out and surveying such a scene.
Thanks very much indeed for this insight into these first three pictures. A quick reaction from you, Jean-Pierre, about these pictures. What's your reaction?
Well, it's really astonishing. I mean, we're really now discovering a Titan from very close, and I'm just astonished by those pictures. And I would really like to congratulate the team for making those pictures available in such a short time. So congratulations, Marty. I'm really.
I'd like to congratulate the engineering teams and the STEC teams and the ESA teams that have made this possible.
Good. Let's go across the pond to Charles Zelachi, across the American continent to Pasadena, Charles Alachi, you're the director of JPL. I believe you're there. What's your reaction, and possibly congratulations are due to your colleague here, David Southwood, no?
Yeah, well, first I want to start by absolutely congratulating David Southwood and Jean-Pierre Le Breton and everybody in ESA. This has been an amazing feat, and here Europe is unveiling for us a whole new planet. And it has been such a great pleasure and honor to work jointly with ESA and ASI for the last 20 years, you know, on this program. And I'm as amazed and fascinated by looking at these pictures as Jean-Pierre and Dr. Tomasco and probably, I'm sure, there's a whole team back there. It's every time you go to a new planet, you are always surprised. And clearly Titan is surprising us, and that's what exploration is all about.
Too early to draw conclusions or similarities between the pictures that the radar instrument for which you're responsible has given us patches, dark patches as well?
Yeah, it's a little bit early because first we took images of the radar in a different location, but already my radar brain is starting to work. Looking at the picture taken from the ground with all these boulders, that's pretty consistent with having a very bright radar patch or radar surface, because these are boulders about, you know, not too much bigger than the radar wavelengths that we're looking at. But until we really do more coverage in the radar and hopefully one day covering the landing site, it's a little bit premature to make any definite predictions.
Good. Thanks very much indeed, Charles Alachi, for being with us, and we congratulate you. Perhaps we can pass now to Bob Mitchell, who is the program manager of Cassini, the spacecraft that took us to Saturn and propelled us last Christmas Day safely on our way towards Titan, a picture-perfect release. And the probe has come up with the goods. You must be very satisfied as well, Bob.
I am indeed very satisfied. My initial reaction on seeing these pictures was, wow, it worked, look at that. But after looking at them a little further and realizing the brand new world, never seen before, always under this shroud, this really is a great day for us. But at the same time, I recognize that this now is the culmination of a long effort that we've had with our European partners. As you just said, the Cassini orbiter has done its part in this activity. We continue now on into our tour of Saturn, but the collaborative effort we have had with our European partners has been a very remarkable, fulfilling one. Over the years that we've worked together, some of the problems that we've had to work and resolve, it's been a very rewarding experience, and one that I will remember for a long time.
Bob, can we make a comparison with previous space exploration feats of this kind, missions that will remain in the history books?
There are a number of similarities between the Cassini mission and the Galileo mission, but I think the highlights for Cassini, of which I think today certainly has to be the highlight, certainly surpass for me what we did with the Galileo mission. And that's saying a lot, because the Galileo mission was also a remarkable, highly successful mission. So this one, I think this is going to be just about at the top of the list in terms of what we have done in terms of expanding our solar exploration.
Thanks very much indeed, Bob, for taking the time to speak to us, and may we wish your Cassini spacecraft now all the best for the next 3.5 at least years around Saturn. Thank you very much for taking part. Right, let's turn now finally to David Southwood. A concluding word about this day and these images. What would you like to say? Perhaps about Europe's role in this adventure?
For me, it shows Europe can deliver when it comes to space. This is a real achievement by industry, by our engineers in ESA, and by the science community. We work with the Americans, but in a partnership. This is the way we should do it. We did our bit. As for what I've seen, I really think this is going to be the highlight of the Cassini mission. I think it's wonderful that our American partners have
allowed us to run off at the top. I just love the idea of there being liquid down there. It's so, you know, for me, I'm an atmospheric. I like atmospheric science. And here you have something with a surface you know is interacting with the atmosphere. It's going to drive the, if there's liquid down there, it's going to evaporate, it's going to rain, it's going to, all those things that we have, we know and love, at least if you live in this part of the Earth. We're going to have that, but with a different chemistry, with a different, it's for me wonderful, and I just want to see how the whole of the suite of information from the probe fits together. I love the pictures, but I tell you, there's a lot more to be fitted on top of them. Thank you very much indeed, David Southwood. Thank you, Jean-Pierre Le Breton, Martin Tomasco. Thank you as well. Well, I will conclude our broadcast for today on ESA television, perhaps by repeating what has been said today, that Huygens, the dream, has come true.
Let's get the latest on the day's event.
More correspondence.
Some warning shots were fired from this Israeli watch. The force of the blast blew debris several hundred meters.
More analysis.
Just how is that investigation going? Quite a lot has actually been said behind the scenes.
Which means if it happens here, 24 hours a day. BBC News 24.
The Huygens probe after a 7-year journey across space.
This is the view on Titan. Orange skies and mist on the horizon. The boulders in the foreground are thought to be snowballs. And from the air, this picture shows a hilly terrain. The darker areas may be liquid, lakes or possibly oceans. There's some indication that there may be waves lapping on a coastline. And we heard the first sound. Possibly a brisk wind. And radar picked up this activity from the clouds overhead. Some think that that's evidence of rain. Pictures and sounds that have exceeded the scientists' wildest expectations.
Well, it's absolutely fantastic. We've got over 3.5 hours worth of data. All of our sensors appear to have worked, all I can say is brilliantly. It's going to take us a long time to unscramble it, but they really seem to have worked well.
More fantastic images are sure to follow. Over the next few days, scientists here will build up a more detailed picture of this extraordinary new world. Palab Ghosh, BBC News, at Mission Control in Darmstadt.
Let's see what's happening in the old world now. Here's Daniel with the weather.